All right, so this is a quadratic looking function. It is curved. So let's see here. So select the interval where h is negative. The interval where h is negative, h is, let's see, h is the function. So h of x is what the way they're writing the function. We had been writing, or typically you see f of x, h of x is fine as well. So h of x is the value of the function. So where is it negative? The output is h of x, which is y. Y is h of x. It literally tells you that right here. Where is y negative? Well, right here, it crosses into the negative, and then it stays negative for this entire interval. I guess you could say this interval, this span of x. So it's from -2 to +3. The function is negative, it looks like. So -2 to +3. Oi, I don't see that. -2 to +3, where the interval where h is negative. I feel like that seems right. -2 to +3. So what could it be? Well, B is true, at least. So let's say that. Okay, so I don't know why it's doing that. Maybe it's saying select an interval and not the interval. So it's saying out of these, pick the right one. Well, that is true. That's the only right one. Don't like the question. All right, erase. Okay, mark the absolute maximum. So that's the difference between absolute and relative. So with relative, it's the little peaks anywhere, right? So in any kind of area where in that area where the peaks, this is absolute though. So there's only one absolute maximum. There's only one absolute minimum. Absolute max here, the highest point of the graph is at 6. The output is 6. So we'll just kind of mark it there. All right. All right, so this says 5 times f of 1 plus 5 times g of 9. So they're using notation here. So this is function notation. You need to understand that f of 1, that's when the input is 1. What's the value of the function f? So the function f is in blue. When when the input is 1, the output is -5. So this is 5 times -5, which is -25. So I did the 5 times this is -5. This is 5 times -5. That's how I got -25. And then plus, this is 5 times g of 9. So 5 times whatever g of 9 is. So for g, which is the purple one, when the input is 9, when x is 9, y is -6. So this is 5 times -6, which is -30. My goodness. So -25 plus -30 is -55. All right. Okay, so this one says, what is the input value other than -7 for which h of x is 3? So for the input -7, the output is 3. So that means there's a point -7, 3. So let's check that on the graph. -7, 3. So that's okay, cool. Is there another input value for which the output is 3? So where else is the y value 3? So that's what I'm going to look for. Where else is y 3? At -7 is, let's just do right here. So the other input would be 5. Awesome. Okay, this one says Princess Tower in Dubai, shout out to Dubai, is considered the world's tallest residential building, towering to 101 floors. My goodness. T of n, the function t in terms of n. So the input is n. So whatever that is, that's the input. T of n models the number of tenants living on the floor n of the tower. So whatever the floor number is, that we can think of that as our input. So if we know the floor number, we can know how many tenants will live there. What does the tenant statement? T of 60 is greater than T of 10 plus T of 30. What does that mean? So basically that just means that the amount of tenants that live on the 60th floor is greater than the amount of tenants that live on the 10th floor plus the amount of tenants that live on the 30th floor. So let's find that answer. This is talking about the heights of the floors. Don't care. We only care about the tenants, to be honest. So C has got to be right. There are more tenants on floor 60 than 10 and 30 combined. That sounds pretty similar to what I said. All right, it's erase. All right, this is select all the intervals where f is increasing. So the function, you can see it's kind of, roller coastering up and down. So where is it increasing? So it's definitely increasing here, decreasing here, and then it's kind of increasing here. So anywhere in kind of the -3 to 0 range for the x values, and and then from 3 up, as far as we know. And this, it looks like it's going to come back down, but who knows? For now, we'll just say from -3 to 0, so that range, and then 3 to 5, for all we know. That's all we know. So let's see what answer it corresponds. So there's a -3 to 0 and 3 to 5. There's -3 to -2, that fits in this range. It says choose all that apply. -0.5 to 0, that's also in this range. And then 3.5 to 4.5 is also, that's in the other range. So all these will work. All right, this says for a given input value R, the function G outputs a value Q. My goodness, to satisfy the following equation. Oh boy, 10Q minus 3R equals 14. So the input value is R of the function G. The function G outputs a value Q. So G of R is Q. Brilliant. So G of R is Q. So the input is R in the function G and the output is Q. Cool. So it's 10Q minus 3R equals 14. Write a formula for G of R in terms of R. So we're writing a formula for G of R, which is the same thing as Q, and we're writing that in terms of R. Nice. So let's basically, this is saying solve for Q. Solve for Q. In terms of R. My bad. Totally got that wrong. Forget everything I just said. In terms of that, in terms of R, so we want to solve for, oh no, my goodness, I had it right the first time. Solve for Q, because what's going to happen, and we'll just solve it. Let's solve it first before I say something wrong again. 10Q minus 3R equals 14. 10Q, add 3R to both sides, equals 3R plus 14. Divide both sides by 10, so Q equals 3/10 R. 3/10 of a pirate plus 14 over 10, which reduces to 7 over 5. So that's a messy, messy answer. So hopefully we get this all right here. And then assuming I get it right, let's explain why it's, we solved it this way. Plus 7/5. So the reason this is in terms of R is because what you're looking at when you describe the function, what you're describing it in is with the letter R. You are describing all the math with the letter R. So the letter R is what we're writing the function in terms of. This is in the terms of R. We're writing this with R, not with Q. So we could have solved for R, and then we would have had a mess with Q, and that would have been in terms of Q. So that's why we did it that way. All right, so this is like more fun with graphing. So it says the perimeter of a rectangle is 35 centimeters. The rectangle's area in square centimeters as a function of its length is graphed. So the area is a function of length. So the input is the length. So this X is the length, and it should be labeled like that. And then the output is the area. So if the length is 10 centimeters, the area is whatever that is, over 72. It looks like everything here is 4. So it should be just under 76. That'll be 76, so it's like 75 or something like that. When X is 4, so when the length is 4, the area is going to be, geez, this is 52, so it's, I don't know, 54, most likely. So yeah, inputs and outputs. The input is the length, output is the area. Let's get to the question, taking too long. What is the approximate average rate at which the area decreases as the rectangle's length goes from 13 to 16? So from 13 to 16, so when X is 13, it is here. So the output is here at 58. So the input is 13 and the output is 58. And then the input is, the next input we're thinking about is 16. And at 16, it's getting smaller. The box is getting smaller, so it's going to 24. So it's asking what's the average rate of change. So what we're going to do is say, okay, if it changed by this much, so what's 28 minus 54? That is 34. So if it changed by 34, it actually went down by 34, and it did that over an interval of 3. So we can divide that change by 3. And did I get 34 wrong? No, 34 is right. 20, 30, 40, yeah, 34. And that's by 3. So negative 34 divided by 3. It's kind of a weird number. It's going to be negative 11 1/3. So that is D. I realized just now that I didn't use the blackboard at all, so cool. So this says g of x equals negative 3x minus 8. So g of what is negative 10? So what x value would we have to put in to make the output negative 10, or sorry, the output 10? So we can figure that out because this is the output. So if we just say it's 10, so we don't have to guess, we can just like, let's say it's 10, and then we can solve. So the function is negative 3x minus 8. And we know that we're going to put some number in that's going to magically make it 10. What number is that? Well, now we can just solve for it, which is cool. So let's add 8 to both sides. We get 18 equals negative 3x. Divide both sides by negative 3. X equals negative 6, because 18 divided by negative 3 is negative 6. So the input required to make the output 10 is negative 6. All right, see a baseball question, that is cool. So we have h of y, so the function h in terms of y, the input is y, that's opposite of what it normally is, models the leading number of home runs for the season y of the National League between the years 2000 and 2010, according to the table. So the input is the season, models the leading number of home runs for the season y. So the input is what season is it, and the output is how many home runs. So let's see what the question is. Which number type is more appropriate for the domain of age? So the domain is the input is the year. So what is an appropriate number type? Real numbers or integers? Years are counting numbers. We'll call those integers. I am not the most solid on definitions of types of numbers, but let's cross our fingers. You look up somewhere on YouTube for that. What is the appropriate domain? So let's see. So the domain is all the inputs. So I don't see why it's not 2000 to 2010. Yeah, and that's the input is y, which is the opposite of what it normally is. Okie dokie. So, I mean, you can look up all the different definitions of types of numbers if that's something you're into. I am typically not. All right, so this says Omar is an elephant promoter. The table compares the number of people who said they would attend the event and the number of people who actually attended it. So we have inputs is the planned attendance, output is actual attendance, it seems. Can the actual attendance be represented as a function of the planned attendance? So can the actual attendance be a function of planned? So the planned is the input. So actual is the output, planned is the input. So are there any inputs with multiple outputs? So 150, do I see that input? Or you can think, so for the input 150, what's the output? It's only 130. For 220, the output is 200. And this down here says 220 is 200. So that's fine. I don't know why it's writing it twice. Well, I guess it seems like on those 2 times where they had a planned of 220, they had an actual 200. So that's okay. It looks like it's not a function because there's 2 inputs listed, but the input only has that one output. I'm going to count it. The input is 200, good, 300. I'm going to call this a function. And say yes. All right, last one. So what is the domain of f? So what are the inputs that can be part of this function f? So what is the domain? What are the inputs? Those are all the x values. So we have -6, we have 0, we have 2, 4, and 7. So -6, 0, 2, 4, 7. So I guess it's giving us a range. Oh, well, I'll select this one just because that's exactly what the domain is, -6, 0, 2, 4, 7. All right, nice. So I have to run at this time. I hope this helps you understanding kind of what functions are, how to evaluate them, how to think of them, not just in terms of algebra and numbers, but also in terms of graphs, and then in terms of relationships between numbers, because that's really all a function is. A corresponding set of inputs and outputs. It's just a relationship between numbers, a relationship between 2 sets of numbers.